Hello students and good morning. So now I am doing class for class 11 science. The topic is the same topic that we were doing in the last online class. That is, the topic is transformation of products and sums. So today is the continuation class of this chapter. So same exercise 5, 2 marks section, page number 148 from the book Higher Mathematics for class 11 by SND. So let's do this question number 2. Prove that. So here question number 1 is sine 75 degree plus sine 15 degree divided by sine 75 degree minus sine 15 degree is equal to root over 3. So let's prove it now. So LHS is equal to, let us write down left hand side now. So here LHS is equal to sine 75 degree plus sine 15 degree divided by sine 75 degree minus sine 15 degree, right? So now in this case you can use the formula. In the numerator you can use sine C plus sine D divided by, in the denominator you can use sine C minus sine D. So I think you know all the formula that we had done in the last online class, that is from this chapter, transformation of products and sums. Okay, so what is sine C plus sine D? So let us write down the formula. What is sine C plus sine D? It is 2 sine of C plus D by 2. C is 75 degree plus 15 degree divided by 2. That is your sine of C plus D by 2. Cos of C minus D by 2, that is 75 degree minus 15 degree divided by 2. Is that clear? 2 sine C plus D by 2 cos C minus D by 2. Next, 2 into, what is sine C minus sine D? 2 cos C plus D by 2. It is C plus D by 2. Then if it is minus, then you should write cos first. 2 cos C plus D by 2, then sine of C minus D by 2. 75 degree minus 15 degree divided by 2. Okay. So here you can cancel, these 2 will be cancelled, which is equal to, now this is sine, what is 75 plus 15? 90 divided by 2, 45, right? 90 divided by 2 is 45 degree. Next, cos 75 minus 15, 60 divided by 2 is 30. It is cos 30 degree divided by, next, similarly cos 75 plus 15, 90 by 2, 45 degree. And then sine of, this is sine of 75 minus 15 is 60 divided by 2 is 30. So this is your 30 degree, right? So which is equal to sine 45 by cos 45 is tan 45 degree. Sine 45 divided by cos 45 is tan 45. Cos 30 by sine 30 is your cot 30 degree. So which is equal to, now these are standard angles, you know that. You have done it in class 10. What is the value for tan 45 degree? It is 1. And what is the value for cot 30 degree? It is root 3. So which is equal to, the answer is root over 3. So it is proved. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is 2 of number 2. That is also prove that. You prove LHS is equal to RHS. The question is cos 45 degree minus cos 75 degree divided by sine 45 degree plus sine 75 degree is equal to 2 minus root over 3. So let us prove LHS is equal to RHS here also. So let us write LHS first, which is equal to cos 45 degree minus cos 75 degree divided by this is sine 45 degree plus sine 75 degree. So now in this case, cos 45 and sin 45 degree, cos 45 degree and sin 45 degree are given here, but you know that these are standard angles, but you cannot put the values of this cos 45 and sin 45 degree here, because if you put the values of cos 45 and sin 45 degree in this case, you won't get the answer 2 minus root over 3. Okay, so let us use here the formula of cos C minus cos D, and in the denominator you can use the formula of sin C plus sin D. Here C is 45 and D is 75. Here also C is 45, D is 75. Okay, so what is the formula in the numerator? Cos C minus cos D. C is 45, D is 75. Formula is 2 sine of C plus D by 2, that is 45 plus 75 divided by 2, that is your 2 sine C plus D by 2, then sine of D minus C, 75 minus 45 degree divided by 2, that is your 2 sine C plus D by 2, then sine of D minus C by 2. Now in this case, since plus sign is there, you may write sine 75 plus sine 45 degree. That means we may take this greater angle as C and this small angle as D, that is sine 75 degree plus sine 45 degree. Let us use the formula here. 2 sine of C plus D by 2, that is C here is 75 degree plus 45 degree divided by 2 into then cos C minus D. What is C minus D? 75 degree minus 45 degree divided by 2. Okay, so here you can cancel these two, and you can cancel these similar terms from both the numerator as well as in the denominator. So which is equal to, in the numerator what do we have? Sine of 75 minus 45 is 5 minus 5 0, 7 minus 4 is 30 by 2 is 15. So this is sine 15 degree divided by, in the denominator similarly cos it will be, what is 75 minus 45? 30 by 2 is 15 degree. So it is cos 15 degree. So which is equal to, what is sine by cos? This is your tan 15 degree. Tan 15 degree, right? Now we have to get the value for tan 15 degree. So which is equal to tan of this 15 degree can be written as 45 degree minus 30 degree, isn't it? So we can convert this tan 15 degree in terms of compound angle form, that is tan of A minus B. This 15 degree can be written as 45 minus 30 degree. So this is tan of A minus B. What is the formula? Tan A, tan 45 degree minus tan B minus tan 30 degree divided by 1 plus tan A tan B, that is tan 25 degree tan 30 degree. Is it clear now? So let us use the value now. These are all standard angles. What is tan 45 degree? 1 minus what is tan 30 degree? 1 by root 3 divided by 1 plus tan 45 is 1. You don't have to write it. What is tan 30? It is 1 upon root 3. Okay. Now let's take the LCM. In the numerator, what's the LCM? It is root 3. Root 3 ones are root 3. It is root 3 minus 1. In the denominator also, LCM is root 3. Root 3 into 1. This is root 3 plus 1. So here root 3 gets cancels. So is equal to, this is your root 3 minus 1 divided by, this is root 3 plus 1. So is that clear? But you have to prove 2 minus root 3. So let us rationalize the denominator. What is the meaning of rationalizing the denominator? You have to remove square root from the denominator. That is, you have to multiply both the numerator and the denominator by root 3 minus 1. So which is equal to, this is root 3 plus 1 is there. Since we are rationalizing the denominator, multiplied by root 3 minus 1. And in the denominator also, this is root 3 minus 1 into root 3 minus 1. Which is equal to, this is root 3 minus 1 whole square divided by, this is a square minus b square, isn't it? that is root 3 whole square minus 1 whole square, which is equal to, what is root 3 minus 1 whole square? A minus b whole square. What is a? What is a whole square? Root 3 whole square. Root 3 whole square is 3 minus twice ab minus 2 root 3 plus b square 1 divided by, what is root 3 whole square? 3 minus 1, which is equal to, what is 3 plus 1? 4 minus 2 root 3 whole divided by 3 minus 1 is 2. So now you can simplify it further. In the numerator 2 is common. This is 2 minus root 3 divided by 2. Here 2 gets cancels. So what is the answer now? Which is equal to 2 minus root 3, which is equal to right hand side. That is proved. Okay, so you can copy it. Now we'll do the next question. So now we'll prove this question. That is, let's do this question number 4 first. That is question number 2. Number 4, you have to prove that. You have to prove that this LHS is equal to RHS. Okay. You prove cos 10 degree minus sin 10 degree divided by cos 10 degree plus sin 10 degree is equal to tan 35 degree. So in this case, we can prove it from right hand side also. That is RHS. RHS is equal to tan 35 degree. Okay. Since we have to prove in terms of 10 degree, this 35 degree can be written in terms of 10 degree. That is, we can write 45 degree minus 10 degree, which is equal to tan 35 degree is 45 degree minus 10 degree. This 35 degree can be written as 45 degree minus 10 degree. And this is tan of a minus b. What is tan of a minus b? Tan a minus tan b divided by 1 plus tan a tan b. You can use the formula from compound angle. So what is the formula here? Tan a. A is here is 45. Tan 45 minus tan 10 degree divided by 1 plus tan a tan b. What is tan a? Tan 45 degree. Then tan b is tan 10 degree. Is it clear now? What is tan 45 degree? It is 1 minus tan 10 degree divided by 1 plus, what is tan 45? 1 into, this is your tan 10 degree. So I think you have understood it. So which is equal to next? Which is equal to 1 minus tan, 1 minus. Now we have to prove in terms of cos and sine. So let us convert this tan into sine by cos. So what is tan 10 degree? It is sine 10 degree divided by cos 10 degree divided by 1 plus 1 into tan 10 degree is tan 10 degree. What is tan 10 degree? It is sine 10 degree divided by cos 10 degree. Now let us simplify it. So in the numerator as well as in the denominator, you can take the LCM. What's the LCM here? It is cos 10 degree. Cos 10 degree into 1. Cos 10 degree minus sine 10 degree. In the denominator also, what's the LCM? Cos 10 degree. Cos 10 degree into 1 is cos 10 degree plus sine 10 degree. So here cos 10 degree will be cancelled, which is equal to cos 10 degree minus sine 10 degree divided by, in the denominator, what do we write? Cos 10 degree plus sine 10 degree. That is proved. So I think you have understood it. Okay, so this is the method. So you can copy it and you can do this to number 3 at home. This is your homework. This is same as, this is similar to question number 4, right? You can prove it from right hand side also. Tan 25 degree is equal to, this 25 degree can be written as 45 minus 20. Then you can easily prove this RHS is equal to LHS. Okay. So in this case also you prove it from right hand side, right? And in question number 5, you have to prove that cos 2 alpha minus cos 2 beta divided by sin 2 alpha plus sin 2 beta is equal to tan of beta minus alpha. You can do it. So you prove it from left hand side. In the left hand side you can use the formula of cos c minus cos d. Here c is 2 alpha and d is 2 beta. Cos c minus cos d, you can use it. And in the denominator also sin c plus sin d. Use the formula of sin c plus sin d. 2 alpha is taken as c and 2 beta is taken as d. So use the formula, you can prove that LHS is equal to RHS. That is, you can prove tan of beta minus alpha. Okay. So now let's do the next question. So now let's do this question number 3. If x cos alpha plus y sin alpha is equal to x cos beta plus y sin beta, then prove that y is equal to x tan of within bracket alpha plus beta by 2. You have to get the value for y in terms of x, alpha and beta. Okay, from this given. So let us write down given out here. Your given is x cos alpha plus y sin alpha is equal to x cos beta plus y sin beta. Okay. So now since you have to express y in terms of x, so you keep the terms containing y on the left hand side and x on the right hand side. Okay, so write down y on the left hand side, that is y sin alpha. Let us take this plus y sin beta to the left hand side, so it becomes minus y sin beta. Okay, which is equal to on the right hand side x cos beta. This x cos alpha is taken to the right hand side, becomes minus x cos alpha. Okay, so now we can take common here. So here y is taken common. Within bracket we have sin alpha minus sin beta is equal to x is common out here. So within bracket we have cos beta minus cos alpha. So I think you have understood it. Okay, so let us get the value for y. What is y is equal to? Y is equal to x into, what do we write now? Cos beta minus cos alpha divided by, this is your sin alpha minus sin beta. So we have expressed y in terms of x. Okay, now since you have to prove y is equal to x tan of within bracket alpha plus beta by 2. Okay, so now in this case let us use the formula in the numerator as well as in the denominator. In the numerator you can use cos c minus cos d, and in the denominator you can use sin c minus sin d. So let us use the formula now. Or y is equal to x into, what is cos c minus cos d? 2 sin of c plus d by 2, beta plus alpha by 2, that is sin c plus d by 2. Then sin of d minus c by 2. What is d minus c by 2? Alpha minus beta. Alpha minus beta by 2, right? Whole divided by, this is cos c minus cos d. Here c is beta, d is alpha. 2 sin beta plus alpha by 2, that is c plus d by 2. Then sin of d minus c by 2, that is alpha minus beta by 2. What is sin c minus sin d? 2 cos of c plus d. What is c here? Alpha plus beta by 2, right? Then sin, what is c minus d by 2? This is alpha minus beta by 2, right? So here this 2 will be cancelled, and this sin of alpha minus beta by 2 will be cancelled. Therefore, what is y is equal to? Or y is equal to x into, what is this sin? That is beta plus alpha, means alpha plus beta by 2. What is sin of alpha plus beta by 2 divided by cos of alpha plus beta by 2? That is your tan alpha plus beta by 2. Here it is tan of alpha plus beta by 2. So it is proved. So it is proved. So I think I've understood it. So you can copy it. Now we'll do the next question. So now we will do the next question, that is question number 4. The question is, if cos alpha plus cos beta is equal to 1 upon 3 and sin alpha plus sin beta is equal to 1 upon 4, and prove that, you have to show that tan of within bracket alpha plus beta by 2 is equal to 3 upon 4. From these two given, you have to prove tan of alpha plus beta by 2 is equal to 3 upon 4. Okay, so here given is cos alpha plus cos beta is equal to 1 upon 3. So let us use the formula in this case. So on the left hand side, which formula is used? It is cos C plus cos D, right? So, or what is the formula? 2 cos of C plus D by 2, alpha plus beta by 2 into cos of C minus D by 2, alpha minus beta by 2 is equal to 1 upon 3. Let us mark it as number 1. Okay. Again, what is the second given? Your second given is sin alpha plus sin beta is equal to 1 upon 4. Right? Now, what will you do here? In this case also you can use the formula sin C plus sin D. Let us take this alpha as C and beta as D. So what is sin C plus sin D in this case? Or this is 2 sin of C plus D by 2. That is alpha plus beta by 2 into cos of C minus D by 2. Cos of alpha minus beta by 2 is equal to 1/4. So let us mark it as number 2. Is that clear? Now, what will you do with this 1 and 2 so that we can prove the value for tan of alpha plus beta by 2 is equal to 3 upon 4. So we will divide 2 by 1. We will divide 2 by 1 because sin by cos will be tan. This cos of alpha minus beta by 2 will be cancelled, isn't it? So let us write here dividing 2 by 1. So dividing 2 by 1, right? So you divide 2 by 1. So let us write left hand side of number 2 in the numerator. That is 2 sin of alpha plus beta by 2 cos of alpha minus beta by 2 whole divided by, in the denominator, what will you write? You have to write down left hand side of number 1 in the denominator. That is 2 cos of alpha plus beta by 2 into cos of alpha minus beta by 2, which is equal to. So now since we are dividing 2 by 1, so now let us write a right hand side of number 2 in the numerator. That is 1/4 divided by, in the denominator you should write down right hand side of number 1. That is 1 upon 3. Okay. Now in this case, let us cancel the similar terms from both numerator as well as denominator. That is 2 will be cancelled. And here cos of alpha minus beta by 2 will be cancelled. Or, so now what do we write in the next step? What is sin alpha plus beta by 2 divided by cos of alpha plus beta by 2? That is your tan, right? So this is your tan of within bracket alpha plus beta by 2, which is equal to, now on the right hand side, let's simplify it. When this 1 by 3, which is in the denominator, if it goes up in the numerator, it becomes 3 by 4, isn't it? So it becomes 3 by 4. It is done. So 1/4 into 3 by 1. So after simplification, you will get 3 by 4. So it is proved. So it is proved. So I think you have understood it. So you can copy it. Now we'll do the next question. So now let's do this next question from 4 marks section from same exercise, exercise 5. Let us do this question number 1. Prove that. You prove LHS is equal to 0. So number 1 question is sine alpha plus sine of within bracket 120 degree plus alpha plus sine of 240 degree plus alpha is equal to 0. You have to prove it. So let us write down here left hand side. So LHS is equal to sine alpha plus sine 120 degree plus alpha plus sine of 240 degree plus alpha. Now since we are doing this new chapter, that is transformation of products and sums. So in this case we can use the formula from this chapter, that is sine C plus sine D. Let us use formula for this second and third term. This third term angle is 240 plus alpha and the second term angle is 120 plus alpha. This greater angle you can take it as C and this as D. 240 plus alpha can be taken as C and 120 plus alpha can be taken as D. So this is your sine C plus sine D. So let us use the formula, which is equal to sine alpha plus 2 sine of within bracket C plus D. What is C? 240 plus alpha C plus what is D? 120 degree plus alpha divided by 2. That is your 2 sine C plus D by 2. Okay. Then next, cos of C minus D by 2. What is C? C here is 240 plus alpha, right? Minus D. This is C minus D is 120. But because of this minus sign, this sign changes. Minus into plus is minus alpha divided by 2, bracket closed. Is that clear? So for these two terms, third term and second term, we are using sine C plus sine D. So we have used this formula. That is 2 sine C plus D by 2 cos C minus D by 2. So let us simplify it first. This is sine alpha plus 2 sine of within bracket 240 plus 120. That is your 360, right? Plus alpha 2 alpha whole divided by 2. Then this is cos. This here alpha gets cancels. 240 minus 120 is 120 degree divided by 2, which is equal to, this is your sine alpha plus 2 sine of. So let us separate the term. You can simplify it further. What is 360 by 2? 360 by 2 is 180, you know that. Plus, what is 2 alpha by 2? 2 will be cancelled, then you will have alpha. And this is cos. What is 120 by 2? That is your cos 60 degree. Is that clear? So which is equal to, this is your sine alpha plus 2 into, now what is the formula sine 180 plus alpha? You know it from trigonometrical ratios of associated angles, isn't it? What is the formula for sine 180 degree plus alpha? We have already done it. 180 plus alpha lies in the third quadrant, and in the third quadrant sine is always minus. And since this is 180 is 90 into 2, that is even multiple of 90, so sine remains same, sine remains as it is, that is sine alpha into. This formula is, what is sine 180 plus alpha? It is minus sine alpha into, what is cos 60? Cos 60 is half. Here 2 will be cancelled, which is equal to, this is sine alpha plus and minus, this is also sine alpha. So both of these will be cancelled, which is equal to 0. So it is proved. So I think you have understood it, so you can copy it. So today we did 6 problems. So you revise all these problems at home. If you have any doubt, or if you don't understand any problem in this case, then you can ask me, then you can call me. Okay, so revise all these problems at home. So you have to revise all the problems that we did so far in this chapter, transformation of products and sums, and then in the next online class we will do more problems on this chapter. So this much is for today.